Okay, let's dive into this. Welcome to the Explainer. Today we're tackling something that is literally going to transform how you write software. We're talking about automated testing, and we're tailoring this entirely around your utility tracker project in Django. Now, I know creating automated tests can kind of feel like learning a completely new language at first, but it is undoubtedly one of the most powerful skills you can master as a developer. It's not just about finding bugs, right? It's about giving yourself a total superpower. Just think about the countless hours you'd normally spend manually doing quality assurance. Clicking through forms, submitting data, checking the database, clearing it all out, and then doing the whole shebang all over again just because you tweaked one tiny line of code? Well, automated testing gets you all those lost hours back. So let's get focused and demystify the magic behind this. Here's the agenda for our little mini quest today. First, we'll meet your robot assistant. Then we're going to cover the Arrange, Act, Assert framework. Third, we'll actually write your first test. Fourth, we'll defeat a pretty common database error. And finally, running and reading your tests. All right, section 1, meet your robot assistant. So a lot of people think testing is this daunting, tedious chore, but it really isn't. Picture this. You build a brand new feature for your app. To make sure it works, you open your browser, fill out a web form with a fake date, type in a fake electricity reading, hit submit, navigate over to the results page, and verify it actually saved. Now imagine having to do that exact same manual process 50 times today, just because you keep tweaking the underlying logic. It's exhausting, right? But by writing automated tests, you're essentially building yourself a robot assistant. You just write a small script once, and this robot tirelessly fills out that form 50 times in a fraction of a second, checking your work every single time you hit save. It makes sure you haven't accidentally broken anything, which gives you the incredible confidence to just write and change code without any fear. Moving right along to section 2, Arrange, Act, and Assert. I want you to keep this rule of 3 firmly planted in your mind. Every single good test follows this exact mental framework: arrange, act, assert. It takes a complex process and makes it super digestible. First up, you arrange. This means you set the stage by creating any fake data you might need, like, say, prepping a utility reading for December. Second, you act. This is where you actually perform the action you're testing, like calling the specific Python function that's supposed to save that reading. And third, you assert. You check if the result of your action is exactly what you expected it to be. Did the database record actually save? Did it calculate the total correctly? By sticking to this rhythm, writing tests becomes a really predictable, logical process. Okay, section 3, writing your first test. Let's look at some code. So, test case is absolute magic. To write our first test, we really need to understand this foundational tool in Django. When you run a test using test case, Django spins up a completely temporary, completely separate database just for your experiments. It builds it, runs your code, and then immediately destroys it. This means you can create, edit, and delete thousands of fake utility readings all day long without ever risking your real, live application data. Your actual users are totally protected from your messy laboratory experiments. Let's look at the actual code in your tests file. We're going to test our services logic here. Notice the function name, test_create_reading service. There is a super strict rule you got to follow here. Your test functions absolutely must start with the word test_. If they don't, Django's testing robot is just going to silently ignore them completely, thinking they're normal helper functions. Inside this function, we kick off the arrange phase by setting up a test date and throwing in some raw electricity and gas values. Then we jump right into the act phase by calling our create or update reading service with that exact data. Now, the absolutely crucial part of this whole process is the final step, the assert. Check out self.assert_. This right here is where the actual evaluation happens. This function acts as the ultimate judge of whether our code behaved correctly. We're literally telling Django, hey, go count the objects in the database right now. That count should be equal to exactly 1. If it's 0 or if it's 2, the test fails and alerts you right away. Assuming it does pass, we then grab that single reading from the database and use assert= again to confirm that the stored electricity and gas values perfectly match the fake data we arranged just a moment ago. And this brilliantly illustrates how we can test even more complex logic. You see, your service doesn't just create new readings. It's specifically designed to update them if they already exist for a given month. So we write another test called test_existing_reading. We arrange by creating an initial baseline reading. Then we act by calling the exact same service again with the exact same date, but this time we pass in completely new electricity and gas values. Finally, we assert that the database still only has exactly 1 record. This proves definitively that your code successfully updated the existing record rather than illegally duplicating it and breaking your entire data structure. It's a total game changer. Section 4, defeating the database error. Now, brace yourself, because we are about to hit an inevitable, real-world roadblock. You write your beautiful code, you run your test command, and bam, you get hit with this terrifying boss battle error message. Permission denied to create database. So what just happened? Well, Django tried to build that magical temporary test database we talked about earlier, but since you're using PostgreSQL as your database system, your specific database user doesn't have the strict administrative permissions required to just spin up new databases and tear them down on the fly. And because of that security measure, your tests are completely blocked from running. But don't panic. There is a brilliantly simple workaround that professional developers use all the time. We just need to contrast our database options for a second. PostgreSQL is fantastic for a live production environment. It's heavy, handles multiple users perfectly, and relies on those strict permissions. But for tests, we can simply use SQLite. SQLite is brilliant because it's literally just a lightweight local file on your computer. It is incredibly fast because it lives entirely in memory or on your local file system, totally bypassing those slow network calls. And since it's just a file, there are absolutely zero complex permission headaches to deal with. We just need to tell Django to switch gears. Here is the exact fix. We dive into your main settings file, find the database configuration, and we add this tiny, clever bit of logic. If test in sys.argj, this simply tells Django, hey, check if the developer is running the test command right now in the terminal. If the answer is yes, we dynamically overwrite the database engine to use SQLite 3. And just like that, we bypass the PostgreSQL permission error entirely. When we test, the database becomes a simple, temporary file that gets created and deleted flawlessly. All right, the final stretch, Section 5, running and reading tests. Open up your root terminal and type in this exact command, python manage.py test utility tracker. Think of this as your activation code. It wakes up your newly built robot, tells it to scour your utility tracker app for any function starting with test underscore, safely switches over to that local SQLite database, and executes every single arrange, act, and assert step at lightning speed. When you hit enter, your terminal's going to spit out some text. Let's decode it so you know exactly what your robot is trying to tell you. Each single dot you see represents one individual test that passed perfectly. If you see the word OK at the bottom, that is the best part. It means everything is in the clear. But here's a pro developer tip for you. Go into your code and purposely break it. Change a value to be wrong and run the test again. You're going to see a fail message. A fail means your application code has a logic bug and your assertion successfully caught it. This is a great thing. It means the test did its job. On the other hand, if you see an error message, that means your test script itself actually crashed, usually because of a typo or a syntax mistake in how you wrote the test itself. Take a moment to really process the difference between a caught bug and a crashed script, because knowing that is going to save you hours of debugging. As you keep building out the utility tracker, I want you to keep this conceptual checklist handy. Whenever you write a completely new feature, always test these 3 paths. First, test the happy path. What happens when the data provided is absolutely perfect and exactly what you expected? Second, test the sad path. What happens if the data is deliberately wrong? Like, what if a user enters a negative number for their gas reading or types text instead of numbers? Does your app handle it gracefully? And third, test the boundary path. What happens right at the absolute limits, like submitting an entirely empty reading or a reading dated in the year 2099? Testing all 3 of these ensures your code is practically bulletproof. So, you now have a robust testing foundation and a functioning robot assistant guarding your code. You've conquered the database errors and you've mastered the assert. But keep in mind, we've only tested the underlying data logic so far. What actually happens when a user clicks a button on your web page? Are you ready to take this superpower and learn how to test your views next? I'll leave you to think about that. Thanks for joining me on this explainer, and happy coding.